friends, hello, Miss Seachuck and Bo here talking to you. We are here to talk to you about some of the topics you guys have been asking me about either through GoFormative or through Google Classroom or through Remind Messages, and I've kind of compiled a list of some questions that you guys have been asking me or some things I've noticed as you guys have been submitting your GoFormatives, which you're doing awesome on. So notice here on my help desk topics to be covered, we're basically going to go over some questions from the 32-1 practice and the 32-2 practice, right? Questions similar to those. And they're going to be like number 1 and number 2 from the 32-2 practice on GoFormative, and then numbers 9 and 12 from the 32-1 practice. You guys have that for reference when you're looking at your GoFormatives. Okay, now, some of the questions you guys have been asking about are the ones like number 1 and number 2 from the 32-2 practice, in which we are looking for measures of the arc given either the arc length or the area of the sector. Now, you have to use some close reading strategies here because notice they're giving you the arc length. So that should trigger for you to start that we are using the arc length formula. And a reminder that arc length is the measure of the arc, so n degrees divided by 360 times the circumference, because the arc length is a fraction of our circumference. So this is the formula. Now from here, we need to decide what are we solving for, because they gave us this time the arc length. They gave us AL, right? And they also gave us the radius, right? Really what we're searching for is N, the measure of the arc. So what we need to do is we need to take, all right, these things that they gave us. So the 9.75 pi is the arc length. And again, what we're looking for is n degrees. And again, we're going to plug in then the radius that they gave us as well, which is 13. Now, as we start solving, we're looking to get n by itself. So we can divide away the pi from both sides. They'll just cancel out. That's nice. And then to get rid of this division by 360 degrees, reminder, we can multiply both sides by 360 degrees, because what's going to happen then is on the right hand side it's going to cancel, and on the left hand side we can just take 360 times that 9.75 that we have, and we get 3,510 on the left hand side, and on the right hand side we have n times 2 times 13, which is 26. Well, last but not least, we want n by itself. We want the degrees, right? We want the measure of the arc. So we're going to divide both sides by 26. So we take the 3,510 divided by 26. Now we get n to equal 135 degrees. That's our measure of the arc. Now on the flip side, for number 2, notice they're not asking you for arc length. They're asking you for the area of the sector this time. So notice it's not arc length, which means we're using a completely different formula, because area of the sector equals n degrees divided by 360, but it's a fraction of the area. So pi r squared. So again, make sure you're using your formulas correctly. Now, the area of the sector this time, they're telling us, is 24 pi, okay? So what we need to do there is we need to plug in 24 pi for the area of the sector. And again, they also gave us the radius. What we're looking for is n, the measure of the arc. So we're going to solve n degrees again, this time times pi times 12 squared. Now from here, same kind of thing we did before. The pi's are going to cancel when we divide. All right, we can multiply both sides by 360 to get rid of this division by 360 in the denominator of the right-hand side. So this time, 24 times 360 is 8,640. Okay, now on the right-hand side, we still have n degrees, but this time we're multiplying it by 12 squared, which is 144. So last but not least, we're going to divide both sides by the 144 to get n by itself. And we're going to get a final answer of 60 degrees. Okay, so n equals 60 degrees. All right, now from here, what we're going to do is we're going to switch gears a little bit, and we're going to talk about finding the radius. So notice it's a very similar question. All right, however, this time we are given the arc length is 3 pi, and we're given the measure of the arc. How do we find that radius? So again, we're going back to using the arc length formula. So arc length equals 3 pi, and then measure of the arc, so n over 360 times 2 times pi times r. And again, this time we are looking for that radius. Well, pi's are going to cancel, which is good news. And then you have a couple options of how you can solve this, but I'm going to start again by just multiplying by that 360 just to stay consistent. So we end up taking 3 times 360, which is 1080. And then on the right hand side, we have 90 times 2, which is 180 r. Divide by that 180, and r this time is 6, and our units were miles, so 6 miles. Now, again, you have to be careful of which formula you're using, because the next one's talking about area of a sector. So they're giving us the area of the sector, but a reminder, area of the sector is going to be your n over 360. So they're telling us the measure of the arc is 225 degrees divided by 360. Again, we're trying to find the radius. Well, for area of a sector, again, pi r squared. So we're solving for that r value. All right. As before, divide both sides by pi so they cancel. Multiply both sides by the 360 so we can get rid of that division. So we're going to take 62.5 times 360. We get 22,500. Right, but that's equal to 225 times r squared. And then next thing, we need to divide by the 225 to get r squared by itself. So we get 100 equals r squared. Now a reminder, r squared is different than 2r, right? We are not just going to divide 100 by 2. What we need to do is square root in order to get r by itself. Okay, so r this time is going to be 10 meters. That's our units. So 10 meters or 10 is your answer there. Okay, so hopefully that clears up some of your questions on that type of problem. From there, a lot of people were having questions on this problem on the 32-1 homework that involved the diameter of a bike tire, and they wanted to know how much ground do you cover after you rotate 50 revolutions. Well, let's think about a bike tire, right? So if we have a bike tire here on my bike, it's got some spokes on it all the way around. Terrible drawing of a bike tire, but you guys get the idea. So this bike tire. Well, one revolution around the ground, right? Imagine we roll one revolution out. This is your circumference, okay? So really the circumference is going to be equal to one revolution of this bike. So initially, in order to find the circumference using the diameter, we could just take 36 pi, okay? Well, 36 pi is again one revolution. We want 25 of those. So we're going to take 36 pi and multiply it by 25 to get our final answer. Okay, so 36 pi times the not 25 revolutions, excuse me, what am I saying 25? 50 revolutions, 25 on your homework. Again, the 50 revolutions that it wants to go around in this particular problem is going to give us an approximate distance of 5,654.9 if we round up miles. 5,654.9 inches is what our units were here. And a reminder, circumference is just inches. That inches squared. That's for area. Last but not least, I've been getting a lot of questions about people and this area of a semicircle problem. Well, a reminder, half of a circle means we want the area, that shaded figure, we want half of the area of a circle. So overall, the area of a circle is pi r squared, right? But we're only going to eventually want half of that. So what we first need to do is find the area of the whole circle. Now notice this semicircle, this distance right here, is going to be your diameter, right? Your diameter is going to be, in this case, if we move all the way from -9 to +7, it's a total of 16 total units, which means the radius of this circle is going to be 8. So first thing we can do is take pi times our radius squared. And in this case, we get 64 pi. But again, we only want half of that value. So what we're going to do instead is we're going to take 64 pi and divide that by 2. So we either get 32 pi or about 100.5 units if we're rounding to the nearest 10. So area of half the circle is going to be 64 pi divided by 2, which again we said was 100.5. And a reminder, with area, it is your units squared. Right? Or you could just say 100.5 if you're typing it into your answer for go formative. Okay. So hopefully these examples are going to help you then moving forward on some of those practice problems. Again, from the practices, the 32-2 practice and 32-1 practice. Keep your questions coming. I can keep posting stuff from here, and hope this helps you. Have a good night, guys.